Hi, I've had some questions about the upstream and downstream reading problems, so I wanted to give you guys an example. But again, real quick, whether it is water and a current with a boat or an airplane with wind current going for or against, just remember, think of one variable as being the speed of the vessel on cruise control, as if there was no water or wind speeding up or slowing down. So you have that speed of your vessel, be it your boat or your airplane, and then you're either going against the water or against the wind, which means that that wind and water would be slowing you down versus going with the wind or with the water, and so that would be speeding you up. So kind of think of it in context of, visualize, am I riding my bicycle with the wind or against the wind? Am I going downhill or uphill? Which is faster, which is slower? So in this example, when we have the airspeed of a plane that can fly 2,400 miles east with the wind, okay, so that is an important piece right there, with the wind in 6 hours. And the return west to the same point, so that means the distance is the same, against the wind takes 8 hours. So it takes longer because it was slowed down by the wind. So we want to find the speed of the wind and the speed of the airplane without the wind. So think of that like the cruise control setting. Okay, so if we look at, get a nice color here. Let's say we're going to let air be the speed of the plane without wind, and we're going to let y be the wind. Okay. Now, we also know, since we're talking about traveling, that this works with the formula rate times time equals distance. So we're going to write there, we're going to go rate times time equals distance. And I always like writing my tables. We'll see if we can fit everything in there. Rate times time equals distance, and this is how I sort of organize the information for myself. Well, we only have one plane, but we have two trips, okay? We have the trip east, that was the one with the wind, and then we have the return trip west to the same point, and you can call it trip A, trip B, as long as you keep it consistent, okay? Now, we know that the plane is flying 2,400 miles east. That is a distance. So we're given 2,400 miles here. Well, and then it says in 6 hours. Okay, so it took them 6 hours to go 2,400 miles east. But then they return west to the same point. Okay, that same point there is telling us it was the same distance. 2,400 miles west, but this time it took 8 hours. So now we have to represent the speed of the wind and the speed of the plane without the wind, okay? So if you're going east, and with east, we were going with the wind. So imagine the wind being with you. It is pushing you, right? Just like if you're going downhill, it's making you faster. So we're going to have the speed of the plane plus the speed of the wind. So they're both going in the same direction. That's why you're going faster. The time is shorter because you're going at a faster rate. When you're going west, however fast you've set your cruise control for the plane, because there's no friction with airplanes and boats, that current of the wind or the water will slow you down regardless. So you're going to subtract that rate, the speed of the boat minus the speed of the wind. And you guys can use, B for boat and W for water or anything like that if that helps. Okay. Now we still have our formula rate times time equals distance. So we've got our rate, which is x plus y, times our time, which is 6. I'm going to put it in the front just because we're used to multiplying from the front, equals our distance of 2,400. But then we also have a second equation where we had a time of 8 multiplied by our rate of x minus y equals a distance of 2,400. So just remember, if we have two unknowns, we must have two equations, okay? So this would be considered equation A, and we can call this equation B. Now, we can either go ahead and distribute, or we can divide both sides by the 6 and then divide both sides by the 8 to get the x and the y alone, okay? So if we divide in equation A, we go ahead and divide both sides by 6. I know I'm kind of squeezing it in there. If we divide both sides by 6, that means our equation A is going to end up being x plus y equals, 6 goes in there 400 times. And then the same thing in equation B, since I haven't distributed it, that's hard to say, multiplied by 8 yet, I can divide both sides by 8. So notice, since there's multiplication there, I can reduce those. Once you distribute, you can't just divide 1/8. Everybody gets divided by it or nobody, okay? So when I divide both sides by 8 in equation B, we get x minus y equals 300. And now we have to solve this system of equations. Luckily, the y's are opposites already, so we don't have to use any multiplication to eliminate. We're just going to combine like terms. We get a 2x. The y's add up to a nice little 0 there. Add these, we get 700. And then if we divide both sides by the 2 to get the x by itself, then we get x equals, what is that, 350? And now, because I told myself kind of what the x and the y represented, then I know that this is the speed of the plane. So speed of plane without wind is 350 miles per hour. But then we also want to know the speed of the wind. So we can use this equation, either of these actually. One of these equations up here, we have the x, we just need to solve for the y. So we can plug in x is 350, and again, this is equation A. 350 plus y equals 400. And so when we subtract 350 from both sides, we get y equals 50. And so we can say the wind is 50 miles per hour. Okay, so just keep in mind that when you're doing these rational equations, well, not here, sorry, these aren't rational, but if you've got a system of equations, some of them may end up being a rational equation, some may give you a quadratic equation. So you just have to go back and go, okay, I'm going to whittle this down. What kind of equation do I have now? Do I need to use my system of equations? Do I need to do a linear equation? Do I have a quadratic? And what are my tools? Don't expect all of them to come up with the exact same format. You have all the tools, you just have to decide which one works here, okay? But as far as those two variables, downhill and uphill, just remember one of them is going to be addition. That's the one where you're going faster. And one's going to be subtraction, and that's the direction where it's slower, either uphill or against the wind. Okay, hope that helps. Talk to you guys soon. Bye.